I want to put together a short video here that explains two different methods for solving problems that involve going from moles to mass or moles to particles or vice versa. So the classical method of solving for these problems has you use what are called conversion factors. So you can take this relationship right here and turn it into two different conversion factors. And so here's my two different conversion factors. 1 mole over 6.02 times 10 to the 23rd atoms, or 6.02 times 10 to the 23rd atoms over 1 mole. And you're going to have to figure out which of these conversion factors you're going to use, and it's going to be based on what you're given. So if I'm given 8.3 times 10 to the 21st atoms, then that means I'm going to want to use the conversion factor that has atoms on the bottom. So I'm going to want to use this one. The reason I'm going to want to use that one is because I'm going to multiply by that conversion factor. I'm going to want to no longer have atoms. So I want to use the conversion factor that has atoms on the bottom. What that means is that my unit of atoms is going to cancel out. It's going to be like I'm taking a fraction times a fraction. Well, if I have atoms on top and atoms on bottom, that unit is going to cancel out. So that's how I decided that I need to use this conversion factor, because I need to have atoms on the bottom because that's what I was given. What this looks like mathematically is I'm going to multiply across the top. So 8.3 times 10 to the 21st times 1 is just 8.3 times 10 to the 21st. I'm going to multiply across the bottom. So that means I'm going to have 6.02 times 10 to the 23rd on the bottom. So what I have here is I need to take 8.3 times 10 to the 21st, and I need to divide it by 6.02 times 10 to the 23rd. When I do that in my calculator, that then is going to tell me how many moles are there if I begin with 8.3 times 10 to the 21st atoms. So when you put that in your calculator, you get 0.014 moles. Now, what if you're given a number of moles? For example, you're given 3.2 moles, and the problem wants you to find out how many molecules that is. So that means I'm going to put molecules on the top, and I'm going to put mole on the bottom, because I want moles to cancel out. I don't want moles anymore. So that's how I decide which conversion factor I want to use. The unit I start with has to go on the bottom of my conversion factor so that I no longer have moles. And I have to make sure that 1 mole on the bottom is equal to 6.02 times 10 to the 23rd. So again, when you've got two fractions and you multiply across, you've got 3.2 times 6.02 times 10 to the 23rd. And then on the bottom, you just have 1 times 1. Well, any number divided by 1 is simply itself, so we can just pretty much ignore that. And we put into our calculator 3.2 times 6.02 times 10 to the 23rd power, and we'll get our answer in molecules. Now that's the conversion factor method, and I'm going to show the setting up two ratios on the next slide. So you should get 1.93 times 10 to the 24th molecules for that. So that's the conversion factor method. Once again, just a reminder that whatever unit it is that you start with, so if you're given atoms, then that means you want atoms on the bottom. So we're going to use 1 mole over 6.02 times 10 to the 23rd atoms. If you are given moles and it asks you to find molecules, we're going to put 1 mole on the bottom, and we're going to put 6.02 times 10 to the 23rd molecules on the top. So you can actually kind of see that if you're given atoms and you want to find moles, you're going to take your atoms and divide by 6.02 times 10 to the 23rd. If you are given moles and you need to find molecules, you're going to take your 3.2, your number of moles, and you're going to multiply by 6.02 times 10 to the 23rd. Next, I'm going to show you how to do the ratio cross-multiply method. So with this method, you're going to take what you're given and you're going to set it over x, what you're unknown, what it wants you to solve for. And instead of multiplying by a fraction, you're actually going to set it equal to what you know about these relationships. So for example, if you know that 1 mole is equal to 6.02 times 10 to the 23rd molecules. To set up this ratio, let's say that you're given moles and you want to find molecules. So you simply set this equal to 1 mole is equal to 6.02 times 10 to the 23rd molecules. Now, how do I know what goes where? I have to make sure that the same units on top of my equal sign are on top on the left and the same unit is on top on the right. So if I want to solve for molecules, that's my X on the bottom, that means that on the right of my equal sign, I'm going to have molecules on the bottom. So if I have 8 moles that I'm given, and it wants me to find out how many molecules that would be, now because this is a fraction set equal to a fraction, I'm going to cross multiply to solve. So I'm going to do 8 times 6.02 times 10 to the 23rd, and then that is equal to X times 1, and X times 1 is just X. So if I do 8 times 6.02 times 10 to the 23rd, then that's going to tell me how many molecules I have. Now, what if I'm given 8.4 times 10 to the 25th molecules, and it wants me to find out how many moles that would be? So again, I want to make sure the same units are on the top as on the bottom. And so I know that there is 1 mole in 6.02 times 10 to the 23rd molecules. So again, to solve for X here, we have to cross multiply. So X times 6.02 times 10 to the 23rd would mean I've got 6.02 times 10 to the 23rd X, and I'm setting that equal to 8.4 times 10 to the 25th times 1. So that means that that's equal to 8.4 times 10 to the 25th. I want to solve for X. So I'm going to divide each side by 6.02 times 10 to the 23rd. And so if I do 8.4 times 10 to the 25th divided by 6.02 times 10 to the 23rd, that's going to tell me how many moles. That's going to tell me my X. So I'm going to do this problem in both ways so that you can see which method that you prefer. So first, always identify what you are given. So no matter what, you always are going to start with writing down what you are given, no matter what method you use. So I'm going to do one method in red, and I'm going to do the other method in blue. So in red, I'm doing the conversion factor method. I'm starting with molecules. So my unit of 6.02 times 10 to the 23rd molecules goes on the bottom, and I want to solve for moles. So 1 mole goes on the top. So to solve this, I'm going to multiply across my top. So that gives me 1.2 times 10 to the 23rd. Then I'm going to multiply across the bottom. So that's going to be divided by 6.02 times 10 to the 23rd. So into my calculator, I'm going to need to put 1.2 times 10 to the 23rd and divide by 6.02 times 10 to the 23rd. Now, for the ratio method, I'm given 1.2 times 10 to the 23rd molecules. I want to know how many moles that is. So I'm going to put it over X moles. I'm going to set that equal to 6.02 times 10 to the 23rd molecules on top, because molecules was on top on my left side, and that is 1 mole, because moles is on the bottom. So again, with this method, I'm going to cross multiply. So I'm going to do X times 6.02 times 10 to the 23rd. So I've got 6.02 times 10 to the 23rd X, and I'm going to set that equal to 1.2 times 10 to the 23rd times 1, which is 1.2 times 10 to the 23rd. I want to solve for X, so I'm going to isolate my X by dividing both sides by 6.02 times 10 to the 23rd, and you can see that the math ends up exactly the same. No matter what, I have to put into my calculator 1.2 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. And when you put it into your calculator, if you do it correctly, you should get 0.199 moles. You could round that to 0.20. And again, it does not matter to me which method makes more sense to you as long as you can calculate it mathematically and solve it and get the right answer.